There was a recent Department of Energy study that showed 19 states in the US have enough wind capacity to fuel all of their electricity demands. So you've got this amazing resource. In fact, there's 7 times more power in offshore wind than we can consume in the whole of Louisiana. So it just shows that potential for offshore wind is there. Not without its problem statements, like we talked about earlier, but that's what we want to shoot for. It's having an actual limitless energy economy.
Welcome to the Blue Economy Primer, a New Orleans-based podcast where you learn from the experts the practical tools and solution sets that will empower your community to adapt and thrive in a new blue era of rising seas and economic discontinuity. Special thanks to the Dan Lucas Memorial Foundation and the Pontchartrain Conservancy for their financial and institutional support of Deep Blue Academy's education and research initiatives.
On today's episode, we are speaking with a key leader of the rapidly expanding and critical renewable energy sector in New Orleans and on the Gulf Coast. James, would you like to introduce yourself to our audience, please?
Yeah, I'm James Martin. I'm the CEO of Gulfwind Technology. I've been here in the city of New Orleans since the end of 2010. And as you can probably hear, I'm from England originally and became a citizen a few years ago. So very proud of that.
Fantastic. It's good to have you here. Can you tell us a little bit about where you're from?
Sure thing. So I grew up in a community on the south coast of England. And it was a small island. It's 70 miles in circumference. It's you can ride your bike around it if you absolutely had to. It's home to about 200,000 people, and growing up there, I didn't realize it is the epitome of a thriving blue economy. I mean, it's got everything. Work, rest, and play is built around the ocean and the sea. Even now, what it does, it's actually an important part of the industrial supply chain for offshore wind across the British Isles. So that's kind of where I like to see the comparison. It's New Orleans is a very similar thing. We're surrounded by water. We've got this amazing lake at our doorstep. We've got these beautiful beaches down to the south, and then we've got this amazing energy economy that we've built everything off, that New Orleans is built upon. Whether it's trade from the very early days and into energy and oil and gas nowadays. So yeah, I like to see. I can certainly draw some comparisons, even though this certainly isn't a small village type feel.
Did you start the company on the Isle of Wight?
Yes. So after spending a number of years with big companies, that you get to see a lot of exposure. So got to see a lot of different manufacturing facilities all around the world. We did start the company back in the community that I grew up on the Isle of Wight.
Could you tell us a little bit about the basic technology? Are you floating? Are you fixed?
That's a good one. So my personal experience has been across all types of wind power. So you could think of the basic ingredients are the same. So you've basically got a lot of the turbine technology today is a 3-blade rotor that's capturing energy from the wind, essentially. And how you get that rotor, so you've got 3 blades that are attached to a shaft and a gearbox and a generator, and they generate electricity. So the varying degrees of how high that turbine is in the air would dictate what sort of tower height, what sort of technology you use. And onshore wind is a very successful energy generation resource here in the States. There's over 70,000 turbines that have been deployed, and there's a very healthy 14, 15 gigawatt per year installation forecast. So it's a really good benchmark industry. Then you get into nearshore. You can some technology that it might be on a jacket. So whether it's a monopile or a 3-legged kind of jacket. And that's the sort of technology that you're seeing out in the East Coast, whether it's the Block Island, which was installed in 2015, or whether it's the more frequent, the more recent large-scale deployment that's happening on the East Coast. And then floating, the next tier. So floating is another level of complexity, and it involves a lot more structure. So now you've got a foundation, maybe the size of a football field, with between 4 to 5 up to 10,000 tons of steel making up that structure that needs to be part of the whole system to get deployed. So the basic concept is the same between onshore and offshore and floating, but there's a lot more complexity as you go further and further offshore and you have more and more ingredients into the mix.
And those are all things that you all are focused on in the process of developing?
Yeah, I think, Gulfwind Technology are really a team that devote themselves to solving problems. So we want to know what the problems are with the industry today, and we want to solve those effectively so that we actually continue to keep the cost of energy low. So we want to basically apply engineers and experience to solving problems of today. The more we know about the problems of today and the trajectory that's got us to today means that we can design things and system designs and turbine technology for the future. So really that's kind of what we're interested in, is what's going on. We want to monitor what's happening today. We do that with a variety of technologies that have been introduced into onshore and offshore systems. And we want to basically make sure that anything that's coming together for future state deployment has a smart approach, that has the right, whether it's the right workforce, infrastructure, designs, like a manufacturing-led design, that you've got the right product chosen, you've got the right technology suite applied to it, and that it's done all around a price point. As we know, energy, if you're producing energy, the most important thing is that end users, get the price of power that they expect. And that drives almost all decisions in wind, essentially, which is the cost of energy. You can't put technology that isn't economic into a system. So that's one of the biggest challenges in the industry today. Whether it's the price increases of commodity materials that need to, you need to put in solutions or learnings to actually mitigate the price increases to end customers, or whether it's just about getting more effective at the way you capture energy from the wind. So more and more advanced aerodynamics, ways that you don't damage structures in hurricanes, which I'm sure we'll come on to. Mm-hmm. These events that can cause a lot of damage, they go into the price of energy. Mm-hmm. So putting tech in to mitigate against that is going to be really important.
What are some examples that you consider sort of the problems of today?
I think there's probably a broad spectrum of challenges. So there's the macroeconomic challenges of deployment and how to get the volume that there's going to be demand for. So that's, let's say one of those problems is, do we have enough manufacturing infrastructure, enough handling and staging infrastructure, enough deployment infrastructure? I guess the best analogy is that you could have all the turbines in the world if you don't have the vessels, the cranes, the workforce to deploy those assets safely in the right place. You're going to have a bottleneck. Mm-hmm. Okay, so that's one of the problems. And you've got to keep you've got to keep monitoring all of those aspects of the supply chain. Are we constrained by materials? Are we constrained by technology? Are we constrained by price point? Are we constrained by workforce? And I think having an understanding of a quantitative understanding of where we are today, region by region, is important. And then putting in systems and behaviours and to solve that problem by the time the market comes to life. Mm-hmm. So something in our region that's a really interesting area is, when is the market for offshore wind in the Gulf of Mexico going to launch? It's a question I get asked a lot. Is it that there's at the moment it will be hard to choose a perfect product for the Gulf of Mexico? Okay, so it's light wind. So it's probably it's much lighter wind in the Gulf than it is on the East Coast or the West Coast. So therefore, you've got to choose or have the right product available to be able to purchase. once you've got that right vehicle, then you come into, well, hang on a minute, it's we've got how many named storms come through a season. So if we're going to look after our assets, warranty our assets, validate our assets are going to be there in the years to come, we need to test that they're strong enough, that there's enough system design that they can be resilient to a hurricane. And the best way to think about it is that a turbine likes to have power, so it generates power, but if it doesn't have, if the grid dropped off, if it lost power, it's going to be much more exposed in a big storm, basically. So in the same way that if you're in a boat, a motorboat or a sailing boat, and a big weather system comes in, you want to be pointing towards that storm. If you go side on, you're much more likely going to have a problem. And it's exactly the same with turbines. So there are concepts, there's ideas to have battery backup, powered backup from a fossil fuel generator, perhaps that's already out in the Gulf, but some way that you keep that turbine safe, if it can't actually have grid connection. Just an example of a problem statement.
What happens with a turbine out in the middle of the Gulf when a Cat 5 hurricane is coming at it? What can you do?
So that's a good point, and it's something that certainly we could model. You can model based on engineering numbers, and you can have a hypothesis or an idea or a suggestion on what might happen. You can even look at similar case studies. There is documented evidence that that certain turbine sites onshore have had Cat 1, Cat 2 hurricanes go over them. There's data to show that. And you've got a variety of success factors there. I know that my team in the past would design a blade to withstand a 200 mile per hour gust. It's basically you're bending this giant blade that's the length of a football field like a fishing rod. It's amazing to see, but you're putting all that energy into it. But a hurricane, as you well know, is turbulent wind. There's a lot of unknown, and we won't really know until we've tried it. Okay. And I think that you're seeing a lot of really exciting tech out there in the industry today. But there is a big problem statement there. I think that's quite exciting. I think that there's standards to be developed, there's tests to be developed, there's examples and demonstration vehicles to be deployed. It's going to be, ultimately, it's the multi-million-dollar question, you can say. But it is possible. From an individual component standpoint, it's possible. From a system design, I think there's a way to go before we're really de-risked anything that might go in a zone like the Gulf.
So it sounds like you're saying we still have a lot to learn, and that's part of the process in terms of answering that question of when will we have wide-scale scaling deployment of wind in the Gulf.
I think it's one of the approaches. Absolutely.
Mm-hmm.
There's you could go with statistics. I think there's a number of conceptual approaches you can take to hurricanes. Do you over-engineer? If you over-engineer something, it's going to cost more. If you have higher safety factors, or do you put a standard product in there? There are turbines out there from some really high quality manufacturers that have been Typhoon certified. So the Typhoon is, it's a few miles per hour short of a hurricane, 20 or so, but the technology and the testing is getting there. Mm-hmm. It is moving in the right direction. But ultimately, there's you got to de-risk it. Someone is making a decision to put billions of dollars of resources in a particular area. You're going to want to have models, have all the latest technology. You've got to look after the people that service it. Something that the ports here in Louisiana are very effective at is how to have ride-out crews, how to make ports secure when a big storm comes in. Mm-hmm. And all of those lessons learned need to be applied to the offshore wind industry in the Gulf. So I think it's not an unsolvable problem. It just needs some time and the right people focusing on it.
In this region on the Gulf, is that the key driving design condition that you're solving for, or is there another key design factor that you need to plan for?
I think it's the combination of low wind speed and high peak wind event. So it's almost like the perfect storm problem statement for an engineering team. You got to have if you take it back to sailing, you got to have a small sail and a big sail all in the same design, and that's really interesting. So there's some, watch this space there. I think there's some really good conceptual designs out there from the current big players in wind and the national labs, but there's really some open space for innovation, and that's really what gets my team really excited, is the innovation potential and the problem solving potential that this industry puts on the table, essentially.
So at Deep Blue, we're particularly interested in innovation ecosystems, and I know you, from what you're talking about, you have a good understanding of that. So some of that ecosystem that you're working in and it's very much sort of a team approach to all these different industries that need to work together. Can you talk a little bit about that ecosystem?
Sure. Well, we'll start close to home. So there's a fantastic community of experts in the region, and I'll start with the likes of, let's start with the states. So Louisiana, through their own economic development programs, there's a lot of historical expertise there on how they've stimulated innovation in Louisiana. Greater New Orleans Inc., GNO Inc., and GNO Wind is a really good example of pulling a number of stakeholders together. You've got Tulane University with the Tulane Energy Institute, great, fantastic skill center that's emerging there. Louisiana Wind Hub at UNO is also fantastic. Then you've got Delgado, which is right near here at Avondale, actually. There's a fantastic center of excellence that's come together for oil and gas, and they're looking to get into looking at how to transpose all of their skills into wind. And then Nunez has recently announced a big wind energy partnership. So, and I'm sure I've missed some off, but I guess the general essence is that you've got this great community of already established institutions that have been in the energy business, albeit through oil and gas for a while, and starting to work with companies like Gulfwind Technology to listen to what needs to happen to make this market ready for launch, if these problems are solved at the end of the decade. And then something I know we were talking about earlier, but the workforce of tomorrow. We're really proud to be working with Jefferson Parish Schools here on the right near the Avondale Tea Park Host shipyard. And these are K through 12, kids that want to get their first engagement in engineering, in technology, in renewables. Partnering up to help them with the STEM programs, the STEM clubs, having a mentor in those early stages of working out what they want to work in, whether it's going into an apprenticeship with companies in the energy industry, or whether it's going on to one of the colleges, the aforementioned colleges, or indeed going on and choosing the right path that works for them in the university space, and then knowing that there's something back here in Louisiana, even in New Orleans and the greater New Orleans region, where you've got this kind of technology, energy, sustainable infrastructure built around the blue economy, which is all about what we're all about here. Mm-hmm. So we're doing similar with Patrick Taylor. Actually, we've got a signed STEM, a STEM partnership with the superintendent.
That's a high school?
Yeah, it's a magnet school for Jefferson Parish.
And is that a priority you took on yourself, or something you were encouraged to do? Or
it's something that we're a small technology company, and we've all got what got us into what we're doing. With me personally, it was having an engineering mentor. I was in a school at 13 years old, and you get a dynamic technology teacher that brings in an engineer with a local company, and you learn about engineering. Otherwise, how does a kid know what engineering is or what manufacturing is? So I don't know. It's worked well. We found that the team enjoys going and mentoring. Like, it brings out the best in engineers, I believe, and then you get this real enthusiasm that we've got to. If this is an industry that's going to kickstart in 2027, 2028, it's the kids who are in the schools now that are going to be the workers of tomorrow. And it's very important that industry throws in at every level, whether you're a small company or a big company, and they do. There's a great track record of companies in Louisiana, in the New Orleans region, putting back into schools and colleges. So the fact that we're here and we're so close to Delgado, Patrick Taylor, we've got JEDCO and GNO Inc. and Louisiana, it's all geared around knowledge sharing, actually, which is pretty good. We're leaning into that as well.
What does that mean? It's all geared around knowledge sharing.
I guess So a great initiative that's been started recently is GNO Wind. Okay, so GNO Wind is a GNO Inc. Company, let's say, and they've seen it as their responsibility, and they've done a very good job of pulling together stakeholders in the wind industry and sharing information about what's coming on, whether it's the market trajectory, whether it's the funding opportunities, whether it's the transition potential that companies that in current industries have in renewables. So, something that Gulf Wind care about, we've been in the industry. We've supported its growth in onshore wind, in global market development. And now we're trying to foster a market closer to home. So, how can we apply what we've learned about the industry to make sure that our home, is more effective? So the knowledge sharing aspect is very important. So each company isn't, starting from scratch or rewriting something that's already been written. A great example that someone gave me was the oil and gas industry really benefited from the investment in the space program, back in the 60s. So all of that scientific discovery, technology development that brought, I think it was over 100,000 people together around a common goal, of having getting technology and humans to the moon. The oil and gas industry benefited greatly from that, whether it was technology, whether it was skilled workforce. My father was in the oil and gas industry in the UK, and he would tell stories about being in the North Sea oil and gas industry, and having the big American companies come over and teach this smaller market ways and methods of being more efficient, more technology. And so it's I think that appropriate transposing knowledge and technology to grow markets and grow industries is really, really important. Mm-hmm. And what the emerging renewable industry has the potential of doing is benefiting from all of that expertise in oil and gas, in the energy addition, which we're talking about. It's not it's important to know that, the demand for energy is, as you well know, it's a huge exponential increase in the demand for energy. It's going to take a variety of energy sources to make that successful. Renewables have a number of problem statements that lots of companies and individuals are looking to address. The stability. You've got a very if you've got lots of wind power, you're very much dependent on if it's windy, if it's solar, sunny, etc. So grid balancing, how renewables work together in a microgrid or sort of system design. And oil and gas have a very important part to play in that as well. So I think that's kind of where I was going with the knowledge sharing, is that it is, we shouldn't assume that renewables has to start afresh. There's lots of experience in it, but it can always benefit from industrial expertise in other energy industries transposed into renewables.
Mm-hmm. So how do you see the evolving relationship between the different energy systems in the region and their potential for integration?
Yeah, I think my prior life, the company I worked for, it was it would provide energy generation capacity to whatever was the most efficient solution. So if it was a gas turbine or a wind turbine, or whether there was a problem statement of storage or grid. And I think for energy to be successful, for energy sources to be successful, it's got to be the right technology in the right place. So I think that sort of system design approach is pretty important, and I think it's going to be something that is going to be emerging in our region, in the Louisiana and the Gulf Coast region over time. It's going to be, what are the solutions for carbon sequestration, and what are we going to do for energy storage? Is it going to be batteries? Is it going to be pump storage? Is it going to be, curtailing certain power sources? Is it going to be hydrogen? Putting hydrogen into pipes, hydrogen into tanks. I think all of these things need to be modelled and demonstrated, and then essentially scaled at the end of it. So great! It's going to be a great decade ahead. Sure.
So it sounds like you don't really see any hard lines between all those different activities and endeavors and industries. It sounds like you see it all as a pretty tight ecosystem.
That's very fair to say. Yeah, I think it's got to be looked at in a holistic nature. There shouldn't be. It's always going to be, in my opinion, more efficient that way. The right decisions are going to be made, and I think that's so having groups, consortia come together in a boundaryless way, without being too cliche, but a way that you can put the demand on the table, or the problem statement on the table, and having each industry, each technical expert, apply their knowledge and expertise to the mix to then put the right plan together. Mm-hmm. And I think that's it, having the right strategic plan for the country, for the region, having the right energy mix, solving the right technology problems concurrently along that plan. There's no point having a plan relying on something that needs to be solved without resourcing it and having people working on it. Lots of things have to happen concurrently for this to be successful.
As it may relate to legacy industries and these new industries that are emerging and the rapid scaling that needs to happen, do you see that as a pretty convivial space?
I think, this isn't, there's my personal opinion on things, and where we're focusing is Gulf wind technology, but there's always competition, I think, but ultimately you usually start with what's the demands of the offtake. So, something like, I think there's some really great work going on with Entergy, in our region, to make sure that they're getting all the data and pulling together, making sure that it's certainly from supplying the grid perspective might be a very different series of discussions versus supplying hydrogen for a particular industry. So I think, in the world that I'm involved with, which is turbines, wind turbines, understanding the economics and the opportunities that wind has for either supplying the grid or supplying hydrogen, or the right placement for turbines, or the right suite of technologies for the turbines, I don't think that's going to cause any ripples. I think it's not going to. I don't think there's going to be any conflicting interests with that. I think everybody wants to see technologies become more efficient, more affordable, lower risk, and I think as long as so in those terms, I think it can all be work in pretty clear harmony.
As a global leader in this space, you must have been courted by a lot of different areas of the world or the United States to move your company to those locations. How did you arrive in Louisiana?
Back in 2010, when we got to the point of the business that I was then involved with, we really wanted to get that balance of infrastructure, workforce, and a supporting you could say state that we wanted to go to. And at that time, it was actually, with offshore wind blades, you need a lot of real estate, and it needs to be next to the water. So, we realized pretty quickly that when something's next to the water, it might be full of expensive condos. It might be actually quite hard to get the real estate you need. We looked at different states all over the US, and without naming them all, when we met the Louisiana state, and actually GNO Inc. at the time, and we were made aware of the NASA Michoud in New Orleans East complex, amazing facility, amazing track record of actually the Higgins boats, with aircraft, with the Saturn V rocket, with the external tank. It was very, very clear that there was a turnkey manufacturing and technology infrastructure that we hadn't seen anywhere else in the world. So having that was a huge step for our company. And moving over to Louisiana and having the support of the state and the region and a willing workforce that had worked on big technical structures before that could arrive, literally out of the gate, getting involved with technology and manufacturing was a real asset. It's something we're doing again. I think we're still massively supportive of the work that's going on in NASA. We're now working at the Avondale shipyard where we are now. Again, an absolute powerhouse of a manufacturing infrastructure, from 26,000 people employed here back in the heyday. Some of the largest vessels for the Navy were actually manufactured out of here. And there's a lot of support for this infrastructure to be leveraged for the offshore and onshore wind industry, both part of the supply chain today. T. Parker Host have already had big barges, ocean-going barges, packed with blades, with turbine components, arriving at the dock, swinging around with those giant 300-ton cranes you can see in the background, but making light work of it. And I think that's the key thing, is that we've planted a flag on somewhere that we know has the foundations of, and has the capability to do what we need to do in the future. So we're making a long-term play here. We're really trying to build a team, build an infrastructure, build a community, build partners around bringing this industry forwards in our region, but doing it by supporting the growth of other regions that are already in the renewable energy business. Part of the 70,000 turbines that are onshore wind today, part of that, the emerging industry that's going on in the East Coast, and obviously the leasing rounds that are just going on in California as we talk today. It's big business. Mm-hmm. The other thing we're excited about is this sort of changing paradigm of energy. We want to get into this limitless energy. We think renewables has a big part to play, and what Avondale can do to support getting the volume of turbines that are needed to the table is quite important.
So when you all were working at the NASA facility, what was it like working with NASA? Was there some clear benefits of having the NASA team nearby? Absolutely.
I mean, the NASA facility, for those that don't know about it, has I'll start with the infrastructure and then I'll go on to the other benefits. But again, if this site has been used to handling, moving, transporting giant structures, and that's very, very important when you're in the wind turbine blade business, because a blade is the size of it used to be the size of a swimming pool, now it's the size of a football field, and it's difficult to handle. So the team at NASA were not fazed by us saying we wanted to build and move and test these giant structures. That was quite novel in its own right. And then you've got the rocket scientists, the expertise, the people that you sat down to, next to at lunchtime, that you're talking about finite element analysis model in engineering or aerodynamics or a new material, and they can relate to it. They're like, wind's good, but it's not rocket science. But they're a friendly bunch. They were engaging, and we actually had employees that had made parts for Boeing or components that had gone onto a NASA rocket that could either support us or put infrastructure in front of us for us to be successful. Mm-hmm. So it was a good fit. It was something novel. I think something that was driven by Louisiana State. It was a very and supported by the federal government, and it's still a very strong asset to date in our community in New Orleans. So, big supporter of that.
Were you able to benefit from their computing power and the modeling that they did?
Yeah, it's a really good point as well. So there's these giant banks of computer that are up in Langley, at the NASA space there. So when you're designing a new structural design for a wind turbine blade, you quite often have to run these very complex equations. And those equations might take multiple days, maybe even a week to run. There's a lot of equations. So leveraging that, actually, again, someone we met at NASA, and we had the ability to run these giant equations on these NASA computers, and you could take something that might take a week and do it overnight. It's a big difference when you're trying to get innovation to product fast. When you're really trying to generate novel solutions and then make sure that you iterating, developing, and getting it through to something that can be commercialized quickly.
So it sounds like you're, in addition to finding talented people here that are either from here or moved here, you're also directly recruiting people from all over the world or the country to come work at Gulfwind?
That's correct, yeah. We've got, and Gulfwind, because we've been, a lot of our team, myself included, we've worked all over the world. We've got partners all over the world. So that's very important to us. Our customers are global, our partners are global. But this is the mothership. This is where Gulfwind technology is founded, is going to keep its roots.
Do you feel like in Louisiana and on the Gulf Coast are all the elements that we need to move forward at pace? Are they in place, or is there anything that we need to develop more or put in place?
I think there's my opinion on that is there's some really great work going on at the moment by the policy teams from. For example, the work that Representative Ogeron is doing down and the team down in a lot of the Port Fourchon, there's a lot of great work going on to get ready. And there may even be a scenario, and I think this is where we've been talking about federal water start point, but there's a really interesting aspect for state waters. And I know there's a lot of interest and there's a lot of work going on in that state water spectrum. And you may even see, what Gulfwind technology, what I guess our belief is that there's an opportunity to put turbines in. There's nothing constraining putting a demonstration turbine in much, much earlier than 2028. So what we really want to achieve is breaking some of the chains a little bit and doing a demonstration turbine. And I think what you will probably see over time are plans for more onshore or nearshore or state plans that might come together to do something to answer your question, to showcase that Louisiana has got a lot of ducks in the row.
Could you talk a little bit about how this may relate to Louisiana being a green hydrogen hub?
Yeah, so, and again, there's a fantastic program that was led by GNO Inc. Called H to the Future, and that is a program that is really designed to demystify and answer that question probably much, much better than I can now. But the aim of a green hydrogen program is that you need to have a renewable energy source to actually crack or create the hydrogen. Otherwise, it's a hydrogen that's any other colour on the spectrum, of which I don't ask me to name, but you've got everything from green to grey to pink and beyond. But green hydrogen needs a renewable energy source to run the electrolyzer to create the hydrogen. And I think there's my personal opinion is there's a lot of potential for that in our region because of the demand profile for hydrogen. Industrial corridor leverages a huge amount of hydrogen. The infrastructure is there, the pipeline is there. It's not. It's something that everyone is very familiar with. The industrial companies are very familiar with. So it's really got a lot of potential. Quite excited about it. And again, if we're the point source extraction specialists, if we're solving the problems for the turbines, programs such as that H to the Future are going to solve and demonstrate some of the other parts of the equation. So it's going to be really exciting.
What about the startup space? Are you seeing startups wanting to move here? Are they aware of and attracted by the things that you're talking about?
Startups are, as you well know, it's extremely difficult. It's not easy to move, to generate an environment that is really supportive for startups. New Orleans is doing a fantastic job at pulling together parts of the equation, and in a number of other industries, and I can't comment. So you see the startup space thriving in huge areas of other, and it's fantastic to see. I think applying those lessons learned, applying that enthusiasm, the horsepower, the funding vehicles to this space. First off, it's about advertising the problem statements, and that's why I'm really enjoying talking to you, Greg, because getting those problem statements out there, knowing where the niche spaces are, knowing where the entrepreneurs can focus, where they technology industries can start to shed a lens, and it's going to come. It's going to come, and I believe that we've got we've got this great incubator in this city, in this state. We specifically to offshore wind and wind energy. I think there's a few early adopters. I'm aware of industries that are diversifying as opposed to maybe new startups. And if you think about what that means, it's a startup within a corporation. So that needs the same attitude. You still need you need that messaging to be clear, to get the big industries treating it seriously. And you need those entrepreneurs drawing themselves to New Orleans to get engaged. And I think through your messaging, Greg, this is a very important part of it. I think getting out there and sharing that this is a friendly, this community is very supportive of technology firms, of startup firms, that there are these centers where you can go and hot desk, or you can have a pretty low burn rate for your early stage capital to get things moving. Mm-hmm. I think that's very important. We need to see more and more of it in the renewable energy space for sure. But I think it's coming.
At Deep Blue, we're very interested in the conversation around a climate tech incubator accelerator.
Something that we believe in here at Gulfwind Technology is that you do need those incubator spaces. So, for example, we're going, the space that you're in here now at Avondale, this is a fantastic space to collaborate and build large assets, technology, showcase things. You've got the beach at UNO, again, that is centered around innovation space and startup friendly space in the renewable energy industry. And Rebecca Conwell and the team, Shafin Khan, are doing a fantastic job at making sure that space is available and, linking it in with the universities. Here at Gulfwind, we working with those universities, those colleges, makes your dollars go further. You can get a bigger team at the table if you lean into those relationships. We're doing the same with Tulane Energy Institute, where setting a project, being part of their project, and having that horsepower arrive. That's how you turn one to many in a startup environment. So I can show there are environments in and around that we can lean into, and going to LED, going to GNO Inc., going to the beach, Wind Hub, these are all places that you could get advice about, of how to get this moving.
Well, James, thank you so much for taking the time to talk to us at the Blue Economy Primer. It certainly sounds like all the right pieces are in place to imagine a New Orleans-based climate tech unicorn in our near future. Congratulations on all the great work that you're doing. There are a million other things that I would love to discuss with you, but we'll leave it there for now and look forward to the chance to have you back to discuss everything that you and Gulfwind have in the works.
Thank you very much, Greg. It's been an absolute pleasure, and we look forward to supporting another one in the future.
Thank you for joining us for the Blue Economy Primer. If you enjoyed today's podcast, please hit the like button, and be sure to visit our website at www.deepblue.academy, where you can access important links and supporting information about today's podcast, send us your comments and or suggestions for potential guests and topics, get more information about our education and training programs, and join our mailing list, as well as make a much appreciated tax-deductible donation to support our nonprofit education and research initiatives. Thanks again to the Dan Lucas Memorial Foundation and the Pontchartrain Conservancy for their critical financial and institutional support. Until next time, when we meet again on the ever-expanding horizons of the Blue Economy.